Hey everybody, and welcome back to Algebra 2 Online. So the plan for today is just to do a few more kind of review problems, like ones we've been seeing really in the last video or ones before that. Nothing new here, just good extra practice to help you get ready for the upcoming assessment. So this first one is just asking you to write a rational function which satisfies these given properties. And personally, I'm a very visual learner, so I would graph this a little bit, just kind of sketch some things out. So we have x-intercepts at 1 and 4, right? And then it's saying that you have vertical asymptotes at -1, right? And x equals 0. So actually, I'm going to switch to red because it's going to show up a little better. And then you know that there's a horizontal asymptote at 1/3. So we're going to call that 1/3. And we've got a horizontal asymptote at 1/3. And then there's a hole in the graph at 5. So 1, 2, 3, 4, 5. We know there's going to be a hole there, but we don't really know where the hole is yet, like if it's up here or down here or whatever. So it kind of depends. So we've got to kind of create a rational function that does all those different things. All right, so now I'm just going to kind of go and start doing some of the kind of filling in some stuff I know, like if there's x-intercepts at 1 and 4, right, then that means that I have, x minus 1, x minus 4, basically on top, right, because if you plug in 1 or 4, right, you'll get 0. So I have to have those factors in there somewhere, right? So that's actually, let's just kind of check these off as I go. We'll say that's the red one. Okay. Then we'll do maybe this one. This is pretty straightforward, right? So if you have holes in a graph, right, those are the ones where you have a factor on top and bottom that would cancel out at that point. So, and give you an undefined thing, right? So at 5, it cancels out everywhere, I should say, but at 5 it cancels out and gives you specifically an undefined spot. So that is like going to be the whole part, right? And then there's vertical asymptotes at 1 and 0, right? So we basically just need undefined things with like a +1 on the bottom and then just a x on the bottom, right? Those two would give me undefined vertical asymptotes like I got over here. And the only other thing I'm missing is the horizontal asymptote at 1/3. So, right now what I've got with this rational function is like an x cubed, basically, right, over an x cubed. And so if we were like to do the trick where when we do the limit out at as x goes to infinity, right, everything would just be divided by x cubed, and basically it would go to 1. We want it to go to 1/3, not just 1. And so in order to get this part, right, we would need to add a 3 on the bottom. If we do that, then everything's going to cancel out, and you're going to be able to have it approach this 1/3 as time goes on. So if you go and like plug that into Desmos or something, what you will see is basically a graph that literally does this, and then it will come down. Remember, you can cross over horizontal asymptotes, but it still will approach it over time. So it basically does something like that. So it does satisfy all the different things, and all the colors kind of correspond to these colors here. So yeah, there's a lot in that question. Honestly, that one question kind of tackles the whole unit, except maybe some of the limit stuff we did, I guess, a bit. But speaking of limits, so the way we find horizontal asymptotes is using this limit out at infinity idea. And so I just want to do 2 examples where I just find 2 different limits, and once I find those limits, discuss whether or not there's like a horizontal asymptote for the graph. So this rational function, the highest exponent in here is 2, x squared, right? So I'm just going to start off by doing, if I'm doing a limit as x goes to infinity, positive infinity, I'm going to just divide out literally everything by x squared. And as long as you do it to everything, you don't change the problem or anything. So that's fine. And then, this will go to 2. This will, well, not actually simplify. That one won't simplify. This simplifies to 1. Here you're going to cancel one of those and one of those. And so then we have limit as x goes to infinity of not 5, but 2 plus 3 over x squared over 1 minus 5 over x minus 1 over x squared. And then at this point we can actually take the limit. So we know the limit of constants are just constants, and then these ones, right, as x gets big, like we were talking, this would get really small, and this would too, right? Because 3 divided by increasingly larger numbers is going to be increasingly smaller. Likewise, negative 5 over increasingly large numbers is going to be really, really small. So this would just be 2 plus 0 over 1 minus 0, minus 0, which is 2. So as you go out to infinity on this thing, it's approaching 2. That's what that means. And so y equals 2 is the horizontal asymptote for that thing. If it approaches a value, it's got a horizontal asymptote. Right? For this one, the biggest exponent is 3. Okay, so I'm going to just start by dividing everything by 3. This one's going to negative infinity. So I would have, basically I'm just going to take x cubed out. We'll just do it that way. So I have 1 minus 1 over x minus 3 over x squared. So in this one, I'm just factoring out x cubed. There is nothing to divide, I guess, on top and bottom. There's no top and bottom. So here I would just do it this way so I can get this kind of fraction into the problem somehow. Then I can actually take limits. So, we know that this would go to 0, this would go to 0. And so it's really the same problem as what's the limit as x goes to negative infinity for x cubed. And if you just think of, x cubed, right, looks like this, right? As you approach negative infinity, right, in x, your graph, crashes down. So this thing would just approach negative infinity. And since that is basically not a number like this, there is no horizontal asymptote, which shouldn't be surprising because this is just a cubic, and it doesn't look like this one exactly, but its end behavior is the same as that one. So so this thing doesn't have a horizontal asymptote, whereas this one does. All right, another really important part in this unit is just solving rational equations. So this one, just a good example of the kind of thing that you could see. So I'm going to always start with these things by just factoring everything. Just leave that alone for right now. So I need to factor the top there, which is n plus 1, over, take out an n on the bottom, n plus 9. And so this is nice because now I can see if I want to get rid of all my fractions, which is kind of the goal in these problems, I could just multiply by the common factor n plus 9 times n, right? If I do that, it will, on this first one, n plus 9 cancel, and I just have n. Then, nothing when I distribute it here. So I just did that one. When I do the second distribute, nothing at all is going to cancel, right? There is no fraction. And then in the last distribute, everything cancels with the bottom, which is nice. So now I've reduced it to just a polynomial. in n here. So I'm just going to do kind of normal polynomial solving stuff. And then probably, actually this is pretty nice because we have n squared on both sides, right? We can cancel that. I was thinking about whether I wanted to move things left or right, but it really doesn't matter because I'll just keep, there is no quadratic in this one. So this is 10n, this is n plus 1, minus 2n, 8n equals 1, n is 1 over 8. And the thing you just got to be careful of in these, right, is you don't want that vertical asymptote. You know, like we had in this thing, there's vertical asymptotes. Well, these two give you vertical, and this cancels out and gives you a whole. But really, I should go back here. So at 5, there was a hole. There we go. So here, you know, if you think about this expression that we had that we started with, there's no way to get 0 on the bottom with 1/8, right? -9 would be an issue and 0 would be an issue, but there's no issue with 1/8. So what you get is actually perfectly good and solves the thing. All right, so this last problem, we're just going to write down an equation for this given rational function, so based on this picture here. So this is a point on the graph, -5, 2.5, and these are holes, which I actually had to draw in because I couldn't do it on Desmos. But there's a hole at 0, and then there's a hole at 1 there, okay? And there's a vertical asymptote right here at -4, okay? So, you know, let's just start with that, I guess. So if we have a vertical asymptote at -4, right, that means we have something like x plus 4 on the bottom, right? Because at -4 would be undefined. If there's these holes, right, that means that there's a common factor of x on top and bottom for the 0 one, because you know those cancel out most of the time, but at 0 you get 0 over 0, which is undefined. So that's how we can deal with that hole. For this 1 right here, you just have x minus 1 on top and bottom, and if you do that same thing, you'll have a undefined thing at 1, but everywhere else it just kind of disappears from the problem. And so that is pretty good, okay? But if you look, I haven't done anything with this, and so we should make sure that this actually goes through that point. So if we just plug in -5, -5 minus 1 is -6, -5 plus 4 is -1, -5 there, and then -6. And if you go simplify this a little bit, this is 30, and then this is -30, right? Which most importantly is not 2.5, right? So that must mean that there's some sort of scalar, right? Like stretch factor, like we've seen way back in like September or something like that, that is giving the curvature here a little bit different stretch than kind of this normal one where it's just a 1 right here. So there's basically some right? There's some scalar. And we just want this thing to equal 2.5. So I'm going to pop down here. So at, so it equals 2.5 at -5, right? So if I plug in -5, right? A lot of this is just repeated from what I just did. -1, -5, -6, and I want this to be 2.5, right? Then, you know, this is canceling, this is canceling. You can see that just A basically needs to equal -2.5, right? If you go and plug that in, then you will get that necessary condition right there. So for the sake of not having to rewrite a bunch of stuff, I'm just going to do this, put a negative 2.5 there, put a little y equals, and you're done, okay? So these are kind of just like the big things that I really want you to know for rational functions. So, you should be comfortable graphing them from equations. You should be comfortable getting equations from graphs, solving them like this, be comfortable doing these limit problems, really mostly to analyze horizontal asymptotes. And this is kind of just similar to the last question, but just knowing all these different parts that go into these rational functions and then making like little rough sketches like this from it. So that is about it.